Assalamualaikum, hello everyone. Our project is HANTU FUSION. HANTU FUSION is a puzzle game built on Malaysian horror folklore. My name is ADIB, and the full team members for this development project are LEONG, ASMAWI, and HARITH. HANTU FUSION is a Malaysian horror themed puzzle game. The gameplay is simple. It's a merge puzzle where players combine ghost spirits or hantu to create stronger, more powerful supernatural beings. The game takes place in a mysterious haunted village filled with local folklore creatures. Your ultimate objective is to strategically merge ghosts to achieve the most powerful entity, the Pontianak. Our objectives were threefold: to design and develop a Malaysian horror theme puzzle that features local ghost spirits, to introduce these traditional legends through entertaining gameplay, and most importantly, for this project, to apply programming concepts in C++ to create a functional and engaging game. Here you can see the game's progression. It uses a 204X style mechanic. Players start by merging two toyo with value of 2 to get an orang minyak with value of 4. This continues through 11 different goals from our folklore, like the penanggal and pocong. The final goal is to reach the Pontianak at a value of 204X. These screens show our art style and a mock-up of the final game board. Now, Asmawi will walk you through our technical flowchart.
Okay, thank you. Now let's continue with the flowchart. So this is our flowchart which visualizes the complete logic of the game. It starts by declaring our variables, the 4x4 grid, the score at 0, and our game state flags. It then displays the initial grid which starts with 2 toil tiles. The game then enters its main loop waiting to get player input WAS or D. When a key is pressed, it processes the move, it moves the tiles, combines any identical values, and increases the score. Immediately after, it adds a new toil tiles to a random empty spot. After every move, the flowchart enters the decision phase. First, it checks is there a tile value of 2048, our Pontianak. If yes, it displays the you win message. If no, it asks the next critical question, any valid move left. If yes, the loop repeats and it waits for the next player input. If no, which means the board is full, and it displays the game over message. Finally, after a win or loss, the game asks the player to play again. If yes, it loops all the way back to the start. If no, it ends. To begin our technical design, we created a problem analysis chart. This was crucial for defining our given data like the 4x4 grid and game state flags. The processing required, such as merging tiles and checking for a win, and our required result like displaying the final game over message.
Thank you, Asmawi. Hi, I'm Leong. Let's map this into an input process output chart. This clearly defines how player input like WASD is processed by the game's logic to produce the final output, which is the updated grid and score. Next, our pseudocode translates that flowchart into a structured code-ready format. The core logic is contained in procedure MING. This MING procedure runs the two MING loops. The outer loop handles playing again while the inner loop runs the actual game. Inside the inner loop, it calls our helper function. It will display game, get player input, and then process move. A key part of our design is modularity. We created an initialize ghost names function to map all 11 ghost names to their values from Toyol to Pontianak. The initialize game function resets the grid and score every time a new game starts. We then created functions for every key action. Display game loops through the 4x4 grid and prints the current board and score. Get player input waits for WASD key and validates it. Process move is the brain of the game, which calls the specific slide and merge function for the direction the player chooses. And add new tile, find a random empty spot and adds a toyo. Finally, the check for win function loops through the grid looking for the 204 Pontianak tile. The check for loss function is more complex. It first checks if the grid is full, and if it is, it then checks for any possible adjacent merges. If there are no moves left, it returns true. Asked to play again simply handles the Y or N input to restart the game.
We move to challenges and lesson learned. Of course, during this proposal, our biggest technical challenge was designing the logic for the process move function, ensuring the tiles would slide and merge correctly in all four directions and only merge once per move. That was highly complex. This led to our main lesson learned, the importance of planning, creating the PAC, IPO, and flowchart before thinking about code was essential. This process showed us the power of modular design, breaking a very complex problem into smaller, manageable functions, made the entire project possible to plan the build. That's all from us, and thank you.